Greetings, and thank you for joining us for another SANS ICS Concept Overview. I'm Don C. Weber of Cutaway Security and a certified SANS instructor. In this concept overview, we're joined by Jake Brodsky. Jake has been working in the industrial control industry since the 1990s. He has participated in the development of several industrial communication protocols, particularly DNP3. Jake joins us to talk about some of the considerations for selecting and implementing industrial control protocols for SCADA communications. If you enjoy this video and the topics we cover in the SANS ICS concept overviews, be sure to like and subscribe to this channel. Leave a comment if you have a question about this topic or suggestions for future content. Greetings. Today I'm joined by Jake Brodsky. He's here to talk to us about SCADA protocols and a few of the relevant points when considering these communications. Jake, can you introduce yourself and the topic?
Sure. First of all, before I say anything else, these opinions are just my own. They belong to nobody else but me. And so they're not to be mistaken for opinions of any employer I've ever had, present, past, or future. So let's see. My background is almost entirely SCADA. I started working on this back in the mid 80s. I worked on an analog microwave network, and it had its own little tiny SCADA system embedded in it, which was kind of interesting. And then I learned a lot more about SCADA, the telecommunications aspects, the aspects about the RTU firmware and things like that, and also the protocols. And eventually getting involved in the DNP3 protocol, and I became the DNP3 chair for about 6 years. You will find my name on some of the earlier releases of the DNP standard, the IEEE 1815-2012 and IEEE 1815-2010. I'm in there. Anyways, so I might know something about DNP3. There are people who know more than I do, but obviously, you know. Anyways, and I've also looked at an awful lot of other things and other protocols because I had to, working for a water utility of significant size. I had to choose protocols that actually helped us out. I had to choose the SCADA protocol we used. And we've been through quite a few. I've also done a lot of control systems engineering. I'm a registered professional engineer in the state of Maryland for control systems. So again, I might know something about engineering too. Mm-hmm. So anyways, that's an overview. And oh, by the way, I'm also a ham radio enthusiast, and I'm very proficient in Morse code. And believe it or not, that actually helps you understand a lot of concepts behind protocols. So
100%. Yeah. No, so, thanks for talking a little bit about yourself. So we're here to talk about SCADA protocols, some of the things that you have experienced. I like the implementation side of it, and to talk about that. So, I know you have a few things to say. So how do you want to broach this subject for the viewer?
Well, I also want to put up the issue about legacy behind these protocols, because they come with a history, and it's not one that we can easily update or replace. It's not something that we can do a whole forklift upgrade. Ladies and gentlemen, if you're used to the IT efforts of you go to an office and you take out all the computers and you put in new computers, and magic happens and networks go through and all kinds of magic happens all at once, and next thing you know, you've got a whole new system and it works. Kind of, sort of, yeah. Well, and if it doesn't, it's okay. You have some growing pains, but it's no big deal. In a control system, there's a lot of infrastructure behind all that, and if you start forklifting things in and out of there, you're going to have an awful lot of stuff out of service and on the floor, and there will be a physical mess when that happens, not a data mess. This is not something you can quickly fix. So when you deal with protocols, what's there tends to stay there. And the DNP3 protocol, in particular, is about 30 years old. It got started around 1992, 1993, something around that time. So it is about 30 years old. And for all that it's been through, it's held up pretty well. Other well-known protocols are like Modbus. Modbus has been around since the 1970s. It's almost as old as TCP/IP. It has held up pretty well too, despite its shortcomings. There's a bunch of different parameters about protocols that we want to talk about. So I'll let you start asking questions and see if we can flesh this out a little bit.
Oh, absolutely. I mean, the first thing I want to dive into is you're talking about replacing things, right? You have to replace a whole lot of things. So just deploying a new server with the updated protocols, and because I'm hearing a lot of people in the industry that are saying, "Hey, we need to select when we're selecting products, we need to select the ones with the latest security features and the latest protocols." And so, as an example, DMP3, you would select something that would be the latest and greatest, maybe like IEC 61850,
Yep.
because it's the more up-to-date protocols, or you'd be selecting versions of DMP3 that have the security of, or the more up-to-date secure implementations of the protocol. So what is your experience around that replacement, selecting new protocols, and what it entails for the people that are actually deploying those new technologies, the upgrade with secure infrastructure?
That began back around 2002, 2003, even before I was a member of the DNP users group. And it's funny, DNP3 protocol has authentication, and not many people use it. And it is intended to be backward compatible with everything else that's DNP3. So if, let's say, you attempt authentication with a device that doesn't know what authentication is, it will respond in a reasonable fashion and say, I don't know what that is, what you're asking me, and here's your error bit that tells you what's going on. I can't parse this for some reason. So there are mechanisms for adding this in. The problem goes back a little bit further than that, because if you have a problem with authentication, or if you have a problem with encryption, what is the end result? You want to go patch something, right? Well, that usually means you're going to make a trip out to the field and patch something. In many cases, you're talking about an RTU that might be on the other side of the country. If it's on a pipeline, let's say, you could be looking at a 4-hour plane ride and a 4-hour drive. And that 4-hour drive then takes you out to the middle of nowhere. And then you do this magic 30 minutes worth of work. And if nothing goes wrong, then you get back in your, you go to a hotel somewhere, and then you make the return trip home the next day. That's a mighty expensive upgrade. So what do? Well, you can get boxes that do encryption separately. And if it's up to me, that's what I'm going to do. I'm going to split out the encryption and the authentication features into a separate box, and that separate box will have something that will handle just the encryption and authentication. And why is that? Because when you go out to the station, you can swap the box out, the encryption box, very quickly, and you'll have maybe a few minutes downtime, and you won't even notice it, because the RTU will store the events and backfill you with the events. I'll talk about that in a minute. But if you're going out to a site and you have to flash new firmware into the RTU, you're probably going to lose a lot of state information. And that's really going to be a problem for operators in the system. So that's going to be a major headache that you're going to deal with. It's not that easy to go patch an RTU. It's a lot easier to patch a separate box. So I'm going to recommend the separate box.
So kind of like a transparent firewall, or some type of like Linux system, Raspberry Pi even, that's in front of that device that
It
has.
doesn't. Yeah, the platform doesn't matter. I mean,
Mhm.
I'm mainly concerned with the box. You give somebody who doesn't necessarily have a whole lot of background. You say, here, take the old box out. Here, put this new blue box in, and the wires go in here. They go in there. They're color coded. That's all you need to do, because I guarantee you somebody's going to be spending windshield time. You don't want it to be your best and brightest going out there, just because you need to patch.
Mhm. So when I think about that, now you're talking about a bump in the wire, and that's which is good from a security standpoint. I start thinking about bumps in the wires and doing intrusion detection, giving me more logging information about certain things that we might not see on those endpoints. But that whole bump in the wire thing is inducing another point of failure. It's also inducing latency. So you know what do you think about those considerations?
If you're using real-time protocols, yes, I can see people jumping up and down going latency, and that's not going to work. So I that's one of the neat things about many SCADA protocols. DNP3 is one of a few that are event oriented, meaning that it doesn't have to be up to date. If it goes down for, say, 5 minutes, it'll say, okay, you ask it what's new. It'll say, okay, at this time this happened, then that happened, then something else happened, and then when the other thing that started this whole thing just switched states again, and here's the whole list of how it happened, and that's fine. So if it takes you 5 minutes to send something from one place to another, does it make a big difference? Usually not. A lot of times when you're dealing with a big system, the critical stuff happens locally anyway. And then the SCADA stuff is supervisory. We always forget what the first letter of SCADA stands for: supervisory. And we always tend to forget that, it doesn't have to be absolutely immediate. And that's one of the things that DNP3 is good at. It allows you to timestamp things from the field. So you don't go prosecuting an operator for an alarm that occurred that was timestamped in the field a half an hour before. You don't have to worry about that. You basically keep 2 times of arrival. OPC UA can handle that. The earlier versions of OPC, like OPC DA, doesn't do it so well. That's another story. Anyways, DNP3 is very good at that. There are other protocols also that are event-oriented that will help you handle that as well.
So I'm kind of, whenever I think about SCADA protocols, I think of ICSCP. I can't remember what it stands for right off the top of my head.
Inter-Control Center Communications Protocol, but yes.
Yeah. So I mean that, and that's what I consider as far as my experience for implementation is more on the energy utility side, and I understand that they're leveraging the ICSCP for those for the SCADA exchange of information. But you're talking about leveraging DNP3 for that SCADA protocol. So should I be expecting to experience that out in the field?
I don't know. It's interesting because and I don't want to get into the details because there's a lot that I don't know about those details, but there are politics associated with this. The politics have things to do with which protocol should we migrate towards, and how should we steer the industry. And there are people with a lot of money behind this, and they have their reasons, and I don't know what they are. So I'm just giving you an overview that there's stuff going on in the background that I don't know.
Okay, so short answer to the question: yes, some people are leveraging DNP3 for site-to-site communications. Is kind of what I'm hearing. But
it is, yeah.
Okay. Another thing that we recommend, as far as whenever I'm teaching the basic course and I'm asking people to consider securing some of these protocols is. As you mentioned, doing it, reconfiguring the endpoints might be expensive, or you're not able to do it because of different factors. So leveraging site-to-site VPNs, so those endpoints that are actually facilitating the hop, those networks that are on either side should be trusted. The hop from site to site might be a third party, or at least going over some publicly accessible wireless type of network. So having those site endpoints, those VPNs, is that a good solution? Does that, in your experience, induce latency? How does that play into it?
Anything you insert in the line is going to introduce latency. DNP3, if you configure it properly, is relatively immune to that kind of latency that you would have, unless it starts getting extreme. Like if it takes you minutes to get the data from one place to another, there's going to be some people screaming and hollering about it. But in terms of figuring out what happened first and how it got the way it was, it's pretty good at that. There are other protocols that do this fairly well as well. The 101 and 104 protocols, there's actually a very long name for it. Thank you, Europeans. You come up with these wonderfully long standard names. It just rolls off the tongue. IEC 61870-5-101 and 61870-5-104. They just, after a while, you can see why people say 101 and 104 protocols all the time.
So 101 is the DNP3, and then 104 is the version. No, it's not. Okay, so
European,
I know 104. Go ahead.
It's the European version. Basically, the story goes that they were trying to come up with the one true protocol of everything, and that never works. And the Europeans got stalled on it, and there were people at Westronic in Calgary that decided, you know what, they've got a pretty good looking frame here. Let's just build something, And so they did, and they called that DNP3. Actually, there was a DNP2. There may have been a DNP2 at one point. There was never a DNP1. But anyways, those are long gone. You'll never see them in the field ever. DNP3 it is. And that actually took off, and then the Europeans realized, oh, yeah, they ate our lunch with this. Let's get the standard done. So they did. and it actually worked out pretty well.
So I was just reading something about Indestroyer 2. I was looking at some network stuff and read through a write-up where Indestroyer 2, the malware that recently came out beginning of last year, if I remember correctly, a part of the payload was interacting with the 104 protocol for utilities out there in Europe. And I was just wondering if you're familiar with that and would have what we were just talking about, implementing the authentication and authorization mechanisms that are built into these protocols. Would that have assisted with preventing some of those attacks?
It depends on what they compromised. Mm-hmm. If you're acting like a man in the middle, authentication will definitely stop that. But if you're not a man in the middle, let's say you compromised the engineer's workstation, well, you've got all the keys right there. Mm-hmm. So you can then run rampant with it. And now that you know what the keys are, yeah, you can put all kinds of stuff in the middle and it'll work. So, you have to protect your crown jewels. And one of the crown jewels in any control system is the engineer's workstation, because it's got to have everything. Otherwise, it doesn't work,
Right. Yeah. So yeah, it's really up to the malware developers of whether they've implemented that portion of the protocol, or are they just doing reads and writes and things.
You could also do that on OPC UA. And once again, it depends on what you compromise. Now, if you are in the middle and let's say, somehow there's a transport going across a hostile network, yeah, then definitely encrypt and definitely make sure that your OPC UA stuff is working properly. But if you're local and you've compromised the engineer's workstation, or if you've compromised an operator station, what do you say? You've got full control already. I mean, there's nothing left to defend. The game over.
Right. So, and I'm trying to think of like the control network side. The operators, the process engineers. How can we add value? So, what am I not asking? Because I'm looking at it from a security perspective. So, what are some points for engineers around selection, implementation, whether it's greenfield, brownfield? If they're going to be planning new deployments, what are your recommendations around that?
One of the first things you got to do is take a look at what your driver actually is. A lot of people are still using OPC DA drivers for DNP3, and DNP3 does not map well into OPC DA. OPC DA was designed for real time. That's it. So you've got an event-oriented driver that may have an old timestamp in it, and OPC DA, well, if you really care about that timestamp, they'll make it available to you in a different tag. You're using what's basically is a point-based system on a tag-based interface, and it really doesn't translate well. And there are people who do it better than others, but at the end of the day, it still involves a lot of work for the client, the customer, and all the integration into the SCADA system to put all the stuff back the way it was in the field. So, you've got this information being sent in the field, and OPC DA does a really poor job at putting it, you've got square holes and round pegs as far as the eye could see, and it isn't going to work. So OPC UA, you have a fighting chance if they wrote a native driver for OPC UA and didn't use an OPC DA plugin into some kind of central device. Unfortunately, that's what a lot of places look like right now. So it's either that or get a native DNP3 driver, and that's expensive. And so there's not a lot of good choices in there, but these are issues that you should look for. And a good integrator knows what this is all about. So this is why you go to the integrators and you say, hey, I'm looking for a way to gather the timestamp information from the DNP3 device and also gather the IIN bit states and the, let's say, any of the flags on individual points or anything like that. I'd like to gather that. And they'll look at you funny at first and go, but don't you get that from OPC? And the answer is not always. Because not all the drivers map that in properly, and it doesn't natively translate into something that the OPC driver has unless it was natively written for OPC UA. And OPC UA is also very bloated, unfortunately, as are most of these protocols. So don't think I'm bragging on OPC UA, but it's big and it tried to be everything to everybody, and it tries to do a lot. And unfortunately, that doesn't fly very well because at the end of the day, it means you've got a huge, massive code, lots of surface area to attack, and it just isn't what you wanted it to be. That's why it didn't take very long at the last S4 conference for the Pwn to Own folk to bust into OPC UA. It's got security features, but the parsing is so damn big that the parsing, all the deserialization and everything else that has to happen with incoming messages is just enormous. There's so much surface area that you're going to find something wrong somewhere.
Because it was built to work, and as soon as they got it working, they put it out.
So. They stopped, yeah. And then they're going to wait for the security problems to come boiling in because we don't have good coding standards for writing this stuff. That's the reality.
That's all across. It's not unique here. I mean, we're seeing that across all of the industries.
Right.
Yeah. Oh gosh, I had a good question. Dang it. That got me so we're going down the direction of implementation and selecting of new technologies. What else should we talk about from that?
Well, there is authentication in DNP3, and there are new features coming up that should make authentication much more palatable to the average person. They're probably about 2 years out, give or take. So the standard hasn't been ratified. So
right. So, and I want to come back because I just remembered my point, and I know it'll drive us in a good direction. So I'm going to redirect.
Okay.
And that is you talked about the owners and operators having requirements, coming up with requirements for what they want to do, and then turning to somebody. And the best way for me to describe that are integrators. So turning to integrators and asking, hey, here's my requirements. I need this information. So how much of a role and responsibility for selecting and implementing these newer technologies and these newer solutions do the integrators play? And what's your recommendations around that?
Integrators are on the hot seat for a lot of this security stuff because that's where a lot of the security stuff begins. And I wish them all the best of luck. They're going to need every bit of it. They have to drink from a fire hose. A lot of the end users don't understand security because they don't even have security features to understand. It's kind of like saying, well, here's how to drive a car safely without seatbelts. It doesn't work. You need the seatbelts. You need the features. And so some of the features that the integrators need to look at are how to handle the keys in a system. And this is one of my rants. And this is one of the things that the newer version of DNP3 is going to have. And future versions of SCADA protocols should all include. And despite everything I said about what it takes to patch a device that's got a problem, if you've got authentication coming out of the RTU and you've got an encrypted link, then you've got a 1-2 layer punch. You don't have to jump and say, I must patch it overnight because problems, Mm-hmm. You can afford to take your time. So bump in the wire, yes, definitely. But in addition to the bump in the wire, also have something that says, I need to see this happen from the master station. So, it's also possible that you might have more than one master station. It's also possible that you might have more than one master station that wants to, where you've got privileges for one and privileges for the other, and they might not be the same. You might have two instances of the RTU software sitting in a rack. You've got one card going to one side and one card going to another side. And, you do have things like change of custody meters where a gas pipeline goes from one territory to another, and you've got a change of custody meter, and somebody's got to read that thing from both sides. Somebody's got to calibrate it. Somebody's got to know what's going on. So you have all these background things that you have to think about. What privileges does each side have?
And that's complicated even more by mergers and acquisitions within those fields, because those types of things that you just described, substations, outstations. I mean, substations you don't usually change hands, but in the liquid natural gas, gas and oil, those change hands. I don't want to say a lot, but they can change hands quite a bit. So, which goes into the complications around those communications, because they want that information, right?
Right, and that also gets back to, what did the integrator get asked to design in the first place? Is there a baseline requirement? And in fact, there are very few. And we should be designing these systems to handle mergers and acquisitions, but we don't. And there is no requirement for anybody to do this. So we have to start thinking very carefully about exactly how what we ask for in our SCADA system. We get exactly what we ask for.
So,
if we don't ask for it, and it doesn't happen.
Yeah. So, and that's what I figured I was hearing you say, which is basically the process owners and operators, the process engineers, whoever, and quality control. Quality control is on the back end, right? Whoever's in charge of designing, making the recommendations. Not recommendations, requirements for that process to include communications, exchange of information. They should understand how to write those requirements correctly. And QA needs to understand how to test those things correctly to ensure that the implementers, the integrators have implemented it the way is expected, both in site acceptance and factory acceptance. Is that kind of a boiled down version of what you said?
Yeah, pretty much. And there are many things that integrators don't do in SCADA systems. If you don't ask them to properly set nice tight timeouts, you won't get nice tight timeouts. You'll get whatever the default was that came from the factory, and from the vendor, that designed your SCADA master software. And sometimes it's reasonable, but more often than not, it's a big guess. They don't know what you've got. They don't know your infrastructure. And that's one of the things that you have to pay attention to. They're building
a skid just to drop it in, right?
Right. They're building a skid, drop it in. Will it work? Yeah, it probably will. Will it run smoothly? It's kind of like an engine. I gave you an engine, but it's not tuned up.
Mm-hmm.
Will it run? Well, yeah, sorta. But is it ideal? No. It's not going to run nicely.
Then got to tune it over time.
Yes.
So big of a challenge, it's just and with so much new expectation on this field. I mean, just the advance of technologies. I say the advance of technologies, but also the not advance of technologies. But the advance of expectation around the technologies, it's difficult to keep up. So to wrap up, what are your recommendations around considering those the advancements of our expectations for this field, especially around communications protocols?
One of the things that occurs to me is that we don't really. A lot of people treat latency as if it's a non-issue. You still have to figure it in, even if it's a SCADA system, even if it's designed to say, while I was down and you were down, or whatever happened, here's what happened. Okay, that's great, but you still have to figure out how it gets there and how it gets presented, and who gets what information. And it's more than that. You have to start thinking about the longevity of the objects that you have in your SCADA system. One of the problems with 61850, and this is true, this is the honest truth, they got started at about the same time as DNP3 did. And think about this for a minute. What they were doing is they're defining objects for equipment that costs many times what the industrial control system costs. If you've got a transformer, you're spending millions on that transformer. So you've got an object that defines it. Does the object tell the engineers who design the transformer how to design that transformer? No, they don't give a crap. They care about designing the best transformer for that application. And by golly, that's what you're going to get. You're going to get that transformer, and it's going to be designed to your specifications.
Mhm.
And oh, by the way, the control system should be designed to follow what the field does. The field does not follow what the control system does. If you've got a bunch of objects, now you've got a bunch of holes, things that have to be filled in. What are those things you're going to have to fill in? There were arguments that went literally decades about this kind of stuff. And this is why 61850, the UCA effort, got stalled for so long as it did. And then in addition to that, it's just now coming out. And oh, by the way, I don't know if you've read their compliance certificates, but they're actually kind of sad. The compliance certificate says this product has not been shown to be incompatible with the standard. Let that sink in for a second. Okay, that's what it says. And I understand that, because the doggone spec is something, from people tell me it's like 1,800 pages long and growing. It's really hard to write things for that kind of an environment. So does 61850 have a future? For limited applications, it probably does, but it's never going to take over the world. It can't. It's too damn complicated.
Yeah, and it's not going to change things just by implementation. All of the considerations that we talked about have to go into the design, development, and deployment of and maintenance of the technologies. Same problems. It's not a moving from DNP3 to 61850, 104 to 61850. It's not just a drop in, now it's secure kind of a thing.
No, it really isn't. And I don't know that it ever will be. One of the reasons why Modbus is still around, it's the cockroach of protocols. You're never going to be rid of it. You can have a nuclear meltdown in this industry, you're still going to have Modbus somewhere. And one of the things about Modbus is that it is simple. It's 80 pages long. That's it. And it's not hard to read. It's really pretty basic. Now, there are problems with Modbus. You know, they don't handle data types very well. But that said, people don't mind it, mm-hmm. because because the flaws are fairly well understood, and people get what they need out of it, even if it isn't ideal. And yes, you have compatibility problems. Like, for example, nobody knows how to send a good string through Modbus. So if you've got a string of information, you know, which way did it, you know, you go from low register to high register? Do you go from, you put the length in the beginning, or do you put quotes around it of some kind, or an escape around it? What do? Do you put a null termination at the end of it? Nobody knows. Everybody does it differently. And that's the reason why Modbus is such a headache. And oh, by the way, the same thing happens with 32-bit counters. You know, 32-bit counters, is it little endian or big endian? Do you put the high part in the low address, or the low part in the high address, or is it the other way around? You know, nobody knows. Now, in DNP3 and in 104, these things are fairly well defined. They have well-defined objects. The problem is DNP3 and 104 also have features in them that look like a really good idea 30 years ago. They do file transfer. They do time synchronization. They do a lot of things that we already have plenty good protocols that do those same things today. So the question is, should we still be doing that with these protocols? And the answer is probably not. Keep it simple and stupid. You know, that's the problem. With age, all these things get bloated. And that's the problem that we're facing now with all protocols. And with the bloat comes more opportunities to attack it.
Right, because when they started doing this, I imagine, and I can see their point. They started developing these protocols back in the days when we were talking about not expecting the IT protocols to be in place, the networking protocols and stuff like that to be able to take advantage of, and therefore, you know, they tried to solve a solution or solve a problem that they thought they'd have but didn't really end up having. So
right, I mean, you've got a boot jack in the middle of the prairie out there with no other infrastructure other than a radio connection and solar power to get back to the message back to a master station 30 miles away. You know, what do you do with a situation like that? Mm-hmm. You know, you don't have internet out there. At least you couldn't up until very recently. Now there's all kinds of internet presence available everywhere across the country. Thank you, Elon Musk, and thank you, everybody else out there. Those things exist. And they existed even before Starlink actually was a gleam in his eye. You know, they VSAT services are certainly out there. Everybody knows what those are. So it is a thing. You can get access to those, but in many cases, especially the older systems, they charge by the kilobyte. So you better summarize things very, very carefully, and that's one of the things that you have to consider when you build these systems.
And another consideration. Yeah, this is a complex topic. We could go on and on about SCADA communications and SCADA protocols, but hopefully this is a good introduction for all of the viewers out there that are coming to watch this. Jake, it's always a pleasure to talk to you. It's I always learn so much, and the questions will be nonstop. But let's go ahead and call it on this. Where can people find you, sir?
You can find me on LinkedIn. That's one of the chief ways people reach out to me. Another way to find me is, let's see, I have an email address. I can post that below. People can contact me that way.
I'll put it. I'll include it in the show notes, and we'll go from there. Once again, thank you very much, sir, and you have a great week. Okay.
Be good.
Roger that, sir. Take care. Bye. Thank you for tuning in to another concept overview with the SANS ICS and Cutaway security teams. Please let us know if there are other topics you would like us to cover in the comments below. If you enjoyed the content, please be sure to like and subscribe to the SANS ICS YouTube channel. This has been Don C. Weber of Cutaway Security. Go forth and do good things.